Okay, thank you very much for that. All right, so we're saying that we are doing what? We want to find ways of writing certain equations that are given in the form y is equal to mx plus c, and that is the standard form. Then once you are able to do this, you are able to pick out what is the gradient and what is the y-intercept. Okay, so sometimes they just give you an equation, then they would say, what is the gradient of this equation? And that equation is not in the form y is equal to mx plus c. So the first thing that you need to do is be able to write it in the form y is equal to mx plus c. Okay, so that's what we're going to do today. Okay, so that is the second one. We'll just do 3 examples together, and then you guys will do the rest. So I'm looking at exercise 6 on page 122. That is where I'm getting these questions. Oh, no one responded about the yesterday's exercise. Okay, someone did respond. I think it was Wayne. Yeah. I will see those exercises when you open. Or if you really want to know your marks for now, just send it to me. Just take a picture and send it to me. Then I'll just mark it right there and send it to you. Send it back to you. Okay. Just take a picture, send it to me. I'll mark it on that same picture, then send it back to you. All right. So do that. Okay. So let's look at the solutions to this. Okay. So, like I said, this is basically you making what is that? Y the tabular formula, and make sure it is in the form y is equal to mx plus c. Okay. Okay. So let's start with the first one, part A. Now this one, we want it to be in the form y is equal to mx plus c. So it means we must have the x term first, and then the rest comes later. So when you are writing, what does this one become? Y is equal to what? So you just have to rewrite it in this form. Make sure that the x term is written first. So in this case, I'll write the x term first. And I see that the x term is negative 2x. Okay. And then I just have, now that one is positive because it has no sign there. So it's a plus 5. So now I've written it in the form y is equal to mx plus c. So what is my gradient? What is the gradient?
2.
Is it 2? Negative 2. Don't leave out the negative sign, right? And then the y-intercept is equal to 5. Don't ask me why I left out the positive. When it's just like that, it's a positive also. So that is how you are supposed to answer the first part. Okay. So the first part was easy because it was already, y was already a subject of formula. Okay. The next one, we need to make y subject of formula. Can we tell me what do we do there to make y subject of formula? Someone please. Okay, no one wants to answer. Making y subject of formula, we take the rest to the other side, right? We can say we are taking the negative 4y remains on this side, then everything else goes to the other side. So we have a negative 2x on this side, because the 0 doesn't do anything, then we have a minus 1. Then after that, we divide by negative 4 throughout by negative 4. It's the same as dividing everything by negative 4 here. You can just put one line. Obviously, these two cancels. Then we have what? Y is equal to, this gives us a positive 0.5 x, and this gives us a plus 0.25. Then from there, we can now see that our gradient is the coefficient of x, so our gradient is 0.5, and our y-intercept is equal to 0.25. Okay, very simple. Can we all do part C? I'll give everyone a chance to do part C. I'll give you like 5 minutes. Let's do part C. Then you tell me the answer. Are we done? Okay, yes, we are done. Okay. Someone is saying time is going, say. Time is going, but I wanted to answer. I wanted you to give me the answer. Okay. So part C. So we are saying 6 minus x plus 3y is equal to 0. Again, we just make y substitute the formula. So it's going to be 3y is equal to an x minus 6. When this one goes there, it becomes positive. This one goes there, it becomes a minus. Then you divide by 3 throughout. Okay, then we have y is equal to, this one is the same as 1 over 3 x, and this one is a 2. So from here we can see that our gradient, is equal to 1/3, and our y-intercept is equal to -2. So that is, those are our answers. Okay. So that is for that section. Okay. That is what we're dealing with that section. Then the last section under straight line graphs is horizontal and vertical graphs. Okay, so these are graphs which you don't need to draw any to come up with a table. Okay? You don't need to come up with any table to draw it. Okay. All right. So these are graphs that are usually written as y is equal to, then you have a number, a constant number, right? Just say y is equal to a, and maybe it's written as x is equal to b. These are horizontal or vertical graphs. All right, so let me show you which ones are vertical graphs. Let's say this is our Cartesian coordinate plane. All right, so when you say the value of x is equal to b, we know that the x is on this. This is the x-axis, and this is the y-axis. So if I say x is equal to b, let's say b is right here. It means that on this graph, x is not changing, it remains b. So a graph that shows that x remains that, you just go to where b is on that x-axis. Then you just draw a straight line through that point b, like that. Vertical line. Okay. So that line represents the graph x is equal to b. Because whatever value of y you change, the value of x remains b. Okay? That is the graph of x is equal to b. So these graphs, the graph of x is equal to, are always positive graphs. I mean, are always vertical graphs, sorry. They are always vertical graphs. Okay? Then the graph of y is equal to a. Let me say this is where a is. So it means that whatever value of x you have, the value of y remains a. So these graphs of y is equal to a, they are horizontal graphs. Okay, they are horizontal graphs. So just know from now on that whenever you have a graph that is written y is equal to something, you just go on the y-axis, then you go where that value is on the y-axis, then you draw a horizontal line through that through that point. Okay, so these ones are simple graphs. Okay, they're simple graphs. The other graphs that that you may be given, I don't know if you have to know them ahead now, but a graph like this, the graph of y is equal to x. Graph of y is equal to x. That graph says that the value of y and x are always the same. So that graph just goes like that in the middle. Let me use a straight line. It just goes like that in the middle, like that. So whenever x is 2, y is also 2. So it's like when x is 1, y is 1. When x is 2, y is 2. So this blue graph is the graph of y is equal to x. Okay. These are now just general things that you need to know. All right? They are now just general things that you need to know. Okay. So that is it with straight line graphs. So now we move on to curved graphs. Okay. We move on to curved graphs. Move on to curved graphs. Okay, so these are quadratic graphs. All right, I think I mentioned it in the introduction that curved graphs are like this. Can you have something like that? Y is equal to ax squared plus bx plus c. Okay, that is what that's where curved graphs come from. And usually for you guys, core guys, you end this is where you end. You can plot these graphs. For extended guys, they will usually now plot other hyperbolas and other types of graphs. Okay, so let's see how to plot such a graph. So we're going to do an example. Right? So what they do is they give us a table that has values already. So the part A of that example says complete table of values for y is equal to x squared. Let me just write this one because it might not look the way you are used to. So y is equal to x squared minus 4x. Okay, so they have that graph, they have a table. For those, there are some values on that table already. Okay. Okay, so we have values of x and values of y. I just want to know now how many values do we have there. Okay, I'll write the values first and then I'll divide it. So we have values of x, values of y. So values of x starting at -2, -1, 0, 1, 2, 3, 4, 5, and 6. Okay, now we just need to split to separate these, put it in tables, right? That, and you can draw your proper tables in your books. Okay, so seems like 6 has enough space, eh? 6 is a lot of space. No. Ooh, what's happening with this 6? It's refusing to be moved. It's fine. It's fine. It's fine. All right, so that's what we have there. And then we have some values. They don't want you to calculate for all those values. They only want you to calculate for some specific values. So for example, here they put an A right here. And then they have a 5 right here. And they have a 0 right here. A B right here. -4. And mind you, this is a B. This is a B. It's not a 6. -4, -3, 0, a C, and a D. So they want us to calculate. The first part is saying complete the table of values for that equation there. So they want us to calculate those values, right? So the calculation is simple. It's the normal calculations we've been doing. You just substitute, okay? You want to find this value A. For A, you're going to put here. I'm going to use this equation. Y is equal to A, so you substitute. We're going to have A is equal to, where there's an X, you put -2. It's going to be -2 squared minus 4 multiplied by -2. Then if you simplify that, you get a 4 plus 8, which gives us a 12. Sure. Okay. Gives us a 12. So A is equal to 12, right? Then you go to the next one, B. So Y is B, so B is equal to, where there's an X, you put a 1. It's 1 squared minus 4 times a 1. This gives us 1 minus 4, which simplifies to be a -3. Okay. Then we have what? C, which is equal to a 5 squared minus a 4. Then we put a 5 right there. So that's a 25 minus 20, which gives us a 5. Okay. And then for D, we substitute Y is equal to D. Then we substitute a 6 wherever there's an X. We put a 6 right there. Then that's a 36 minus 24, which gives us a 12. So these are the values. These are the values that are supposed to be right here. These points, né? These points. So now we know that this value here is a 5. This is a 5. Now we know that B is a -3. We know that C is a 5 and D is a 12. Okay, that is the first part of the question. Complete the table. So you complete this table and you get your marks. Any problems there? Any problems?
No, sir.
Okay, no problems. So B says on the grid, plot these and then draw. I can't see something is popping. And then draw the graph. Draw the graph, right? For values of Now they give us the values. So the graph, obviously we know the equation for the values of x that start from what? From -2, obviously, to 6, as it is shown in the table, right? So we are supposed to come up with a grid and then we plot those graphs, plot those values. So everyone right now, I hope you have your what is that? Your graph book.
Please repeat that again. I didn't hear you.
Repeat what?
Repeat what you said. I didn't really get what you said. It was cutting.
Okay, I'm just reading what I was typing there. Okay, I said on the grid, plot these values and then draw the graph for the values of x that are given by that. You can see that x is starting from -2 to 6 right here. So they just want you to plot these graphs, plot the graph. So you're supposed to draw a grid. Now, remember, we're drawing a Cartesian plane. It's going to be something like that. So normally, you guys would want to just in the middle, then you join them in the middle. But you should know what values do you want. By that I mean, let's look at the x-axis. You look at the positive side, the biggest number is 6, and the negative side, the biggest number is what? -2, in terms of the value, right? So it means that you need the positive side of your x-axis to be having a bigger space. You need a bigger space on this side, right? Than on this side. On this side, you only need -2. On this side, you need until up to 6. So this is for now. This is for extended people, basically. Because for core guys, I don't know, we'll check. I think maybe it's for high level people, maybe. Because they would have given you a graph that is a scale already, okay? But you see why I moved this is because I need more space on this side here because I need to get up to 6, all right? That's why I moved this graph there. So I know that for x-axis, if I make this one my origin, if I make this point the origin for x, okay? Then I know that I can have what? -1 here and -2 there. Then on this side, I'll go up to 6. Okay, that's what I mean, right? But I'm not putting these things yet. Then if I look at the y-axis, I look at what is the biggest negative number. It's -4. The biggest positive number is 12. So I need a bigger space on this side than down there. So what I'll do is I'll move the x-axis and take it down there, okay? So that I can have 12. I can go up to 12 on that side, and just here I go up to -4. So that's what I wanted to do. So with that, I'll have enough space. But you don't have to worry about that because you guys are gonna be given a graph that is a scale already. So we have 0 here, a -1, the -2. Then on that side we have a 1, 2, 3, 4, 5, 6. Again, remember this graph is not going to be perfect because I'm not using a graph paper. If I was using a graph paper, I would have been okay. I will show you after this. I will show you on Excel how the graph is supposed to look like, the actual graph. Okay. Okay, because of that, let me just open the Excel already so that I will not have to wait for it to open. Okay. All right, now we put our scale for the y-axis. So the y-axis, we need to go up to 12. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Then here we have -1, -2, -3, and -4. So we came up with what? Our Cartesian coordinate system. You put your x-axis here, you put your label your y-axis there. So, okay. Then we start plotting, okay? We start putting our plots. Let me plot in blue. So we have x is -2. So I'll use those lines. Remember the lines I was using yesterday? So you just try and have I'll have a vertical line. X is -2, so that I see where they're meeting, right? What we really need is the point where they meet. Okay. You know, if this line is vertical, it's refusing to. Okay, maybe it's better now. Okay, that's x is what? -2, and y is 5. Y is 5 is right here. That point right there. So let me just do this. Okay. So they meet at that point. So that is what? Where our point is. Okay. That is where our first point is at x is -2, y is equal to 5. Then we go to x is equal to -1. So we move this to go to that point, and x is equal to, and y is equal to, is it 5 also? Yes, it's also 5. Strange, ne? Let me see if I copied it correctly. So I made a mistake here. It's supposed to be 12. I'm supposed to put a 12 right here. Okay. We calculated it as 12. So okay, so it's not that. It's not correct. This part is not correct. So it's supposed to be 12. So when x is -2, it's a 12 right here. So that is the first point. That is the first point. Then now, when x is -1, and then the y is a 5, and they meet at that point. Okay. So you can use the rulers, but you know how to plot anyway. But just to make sure, because sometimes you guys make mistakes. Then point 0, 0, you can see 0, 0 is this point, right? Okay. If I moved those lines, they would come right here and right there. So that's 0, 0. They meet it right at that point. Okay. All right. So now the next point is when x is equal to 1. So when x is equal to 1, d is -3. Y is -3. So it's at that point. So this point right here. When x is equal to 2, it's -4. It's -4 right here. And when x is equal to 3, this is at what? -3. -3 right here. The x is at 4. This is at 0. Yeah? So 4 and 0 is right there. That's where they meet, right here. Then when x is 5, then it becomes also a 5. Becomes a 5 also. We plot that point. Then the last point, when x is a 6, then the d is a 12. Yeah? So it goes up there, becomes 12. Okay, so those are the points that we've plotted. And you can see that these points represent a curve. Okay? Now the part that is tricky is the part where you have to join those points, right? But you have to join, sorry, join those points. Now you have to do it smoothly. Now I'm using my mouse, so I'm not experienced to draw that curve, so I might miss the point. So you're supposed to draw something that looks like that. Okay, like that, like that. It's supposed to be a curve. So it would have curved. So it was somewhere here. You see what I'm doing now? This is not allowed. So if your graph has two lines like this, you lose marks. Your graph is not supposed to have two lines. It's supposed to have only one line. Okay, only one line. So make sure when you're drawing your graph, it's one smooth line. It's one smooth line. And the reason why I even made it the thickness thinner is because the thickness must be sharp, right? Don't have a thick pencil. Okay, so that is how your graph is supposed to be. Let me remove these two lines because they're not supposed to be there. So that is your graph. So make it as smooth as possible. I actually tried. Something like this is maybe acceptable. Okay. Those that have flexible rulers, you can use a flexible ruler that is able to curve, but they have a smooth curve in the end. When I was in ordinary level, I would use a refill. You know the refill, that thing that has ink in your pen because it's flexible. I would use that, especially when it comes to this part. But that's what I would use throughout. Okay. So that is how you plot that graph. All clear? Is everything clear?
Yes, sir.
Okay.
Yes, sir.
All right, good. Now we continue to part C of the question. The question goes on, right? Part C. Use your graph to find the two values of x when and they say this. When x squared minus 4x is equal to 2. Remember the name of this equation is y is equal to x squared minus 4x, right? That's the equation. Now they're saying that when it's equal to 2, can you solve it? Tell us the value. Tell us the value of x when this graph is equal to 2. What do we do? If you look at it very well, the only thing we replaced was y, okay? When this graph is equal to 2, this graph is equal to 2. It means you now know y should be equal to 2 at that point. So what you simply do is you go to where y is, right? You get y. When y is equal to 2, that's what you go to. They're saying that when this graph is simplified, when the value of y is 2, that's basically what they're saying. Okay, that's what they mean. Because they replaced y with a 2 right there. You can see that we had a So they're just saying when when y is 2, that is 2 is equal to x squared minus 4x. What is the values of x? So what you do now is at that point, you go and read that value there, and you also go and read that value that is there. So now, because of my scale, you can even see that my scale on this side is bigger than on that side. So on my graph, it's very difficult to see, okay? It's very difficult to see on my graph. Okay, so because of that, let's just quickly do this together. I'll plot the graph on Excel, and then we see the actual values, okay? Then we answer the other question. So we're going to finish up at C to F on the Excel so that you can actually see the real values. Ne? So we have 10 minutes, we are able to finish within 10 minutes. So let me do this. Okay. So we need the values of X and the values of Y. Values of X are moving like it's -2, then -1, and 0. So those that would want to know how to use this, it's very interesting. And it does that. We go to 6. Okay, 6. So it gives us the values already. Then this one was 12. This one is 5. This one is 0. Let's see if it will be able to give us the correct answers. I doubt if it will give us the correct answers if we continue. Yeah, it doesn't give us correct answers. Okay, this one, what was our, when it was 1, B was what? -3. And for 2, it's a -4. For 3, it's a -3. For 4, it's a 0. For 5, it's a 5, and then we have a 12. Okay, so we want to plot these values here. So we insert a graph, and we want, okay, this one that shows us the values. Okay, then we put the data. The data range is just that one. Okay, that one there. All right, the X values. So we want the X values. Okay, those are the X values. Those are the Y values. Okay, it's good. Let's see. So that is the graph. Let me just expand it so that you can see. You can all see, right? Can we all see?
Yes, sir.
Okay. So that is the actual value. So now, if we now want to find out when y is equal to 2, what is the value of the equation? So say that we do this. Let's draw the line. I'm not going to use the tools in Excel. That one will be too complicated for you. Let me do this. We just go to that point. We said it's at this point. Let me use a thinner line. So it's at that point right there. So you draw in your equation, in your book, in your graph, you draw a line like that. Then from that point, you see that this is the value you want. And from that point, we see that this is the value you want. Okay, so you show these lines on your graph. We show those lines. If you don't show it, then they would think you did something else. So you show those lines there. So, but basically you are reading this value, okay? So if I try to read this value right here, it's not really telling me the value. I don't want to use the Excel tools because it's to be difficult. But from here, what do you think this value is? The value of X there. So we're answering question C, right? We said C is saying that what are the values of x when x squared minus 4x is equal to 2. So the value of x is, what is this value right here? And what is this value right here?
I'll say 4.3.
4.3. Okay, 4.3. And what did they say in the book, in the answers here? They had 4.4, okay, which is close, you see. So you said 4.3, okay. And for the other value, because there are two values, right? There is one value here and one value there. What is this value to you?
I'll say 0.2.
Negative 0.2, because it's now on the negative side. So what they do is they will have a range in the exam. They have a range. So they would say, here the actual answer is a negative 0.4, right? So what they will say, 4.4 here for 4.4, they have a range, they say plus or minus maybe 0.1, right? So meaning that if you have a 4.3, if you subtract 0.1, you'll be correct. And if you have a 4.5, your answer will be marked correct, okay? And here also they will have a plus or minus something. I don't know the actual range, but 0.2 is not in this range. It would not be accepted. At least if it was a 0.3, then it would be accepted. So that is how you solve the part C. Okay, that is how you solve part C. The other part now, part D. I don't know if you guys are following the textbooks. If you're following your textbooks, they gave you another table. Then they said complete the table for the values of y is equal to 3 minus x. And the table, their table has values of okay, x and then y. Let me do this. Okay, values of x. They have what, negative 2 here. They have a 2 there. They have and a 6 here. Then they have x is right here. Okay. So let me do this quickly. So our table, the table that is in your book is like this. Okay? That's your table. So you need to fill in these values here. And you guys now, you should be able to fill in those values. Okay? If you substitute negative 2 where there's an x here, you get a 5 right here. Okay? If you put this negative 2, if you put it here, you get a 5. And if you put a 2 right here, you get a 1. And if you put a 6, you get negative 3. Okay, so these would be your values. These will be your values for that graph, for this equation. Then they would want you to plot the same equation on the same graph here. Okay, they would want you to plot the same equation on the same graph. So we would have to now select that again and put in some values. We need to add that the range needs to be changed. The range needs to be changed. I don't know if the range now will cover everything. Okay. Okay, that might take some time. That might take some time. Let me just do this add a series. this one here. Okay, it's not allowing me. I'll add X values. Can't see where they're ending. I hope this is it. I'm just suspecting. Just hold on. Something is happening now. Okay, it's fine. So if you're going to plot, let me not waste time. Let's just plot on that graph. If you're going to plot, that's -2 and 5 when X is -2 and this graph is a 5. This graph would have been here, right there. Yeah? Would have been there. And then a 2 and a 1 when X is equal to 2, Y is a 1. Y is a 1 somewhere there. And then a 6 and a -3. 6 and -3 is somewhere here. Now, if I join those lines from that point to that point, you see now, see the graph we come up with. Okay, let me erase, okay, that part because we already answered that part. In your exam, don't erase, ne? Okay, so this is the new graph. This is the graph that is coming from Y is equal to 3 minus X. And remember, this graph is Y is equal to X squared minus 4X. So you plot the graphs. Then they would say, in the end, they'll say solve when X squared minus 4X is equal to 3 minus X. So when the two graphs they meet at this point right here. So when they say solve, you're just going to go to those points and you read this value here, and you go to that point and then you read this value right here. Okay. That is how you're supposed to do it. I think this video might be now longer. I don't think I'll be able to share it on WhatsApp. So what I'll do is I'll just upload it on YouTube, then I'll share you the link, then you can watch it on YouTube. Okay. Anyway, this was it for today. I hope you understood. If you didn't understand, you can just obviously rewatch the video and see and where you did not understand. Eh? All together. So as for your homework, the homework you are doing it in exercise 8. Yeah, exercise 8 on page 125. It's just one graph. Eh? Exercise 8 on page 125. So they also gave you a graph. The scale is given there. If you don't have the textbook, then you're just supposed to, let me just share the picture. Then what you're just supposed to do is you draw your own graph. Ne? Okay. Is everything fine? Are we happy?
Sir, do you write it when you are writing the equation in the graph? Do you write it in a pencil or with an ink? Cause
Okay.
yeah, do you write it with a pen or pencil?
Write it with ink. But if you are not sure whether what you did is correct, you start with the pencil. Eh? Just start with the pencil. Everything when you're dealing with graphs, start with the pencil. Only put the inks when you are sure. So the ink is only on the labels, the Cartesian plane, and also when you label the graph. Eh? Okay, so have a good day. Tomorrow, I would want to have a class with only the extended students, but we'll have to meet earlier. We'll meet earlier, maybe at 9 o'clock. Okay?
Yes, sir.
All right.
Yes.